Hello, good afternoon, everybody. Thank you very much for being on the other side of the screen. And as we don't have very much time for the presentation, we're going to focus on the topic. I'm Manuel Lobo from Finsa. We are a company that produce products that are made in wood, some of which we're going to see have been certified by the Passive House Institute as airtight Class 1 products. And we're going to talk about preventing condensation, particularly when we're talking about light framework. And this is because humidity is a great enemy of construction materials, and it has a huge impact on habitability, occupancy, because if this happens inside homes, it's really bad to live in them. When we work with wood, you have to make sure that there's no humidity because it's a key element for the durability of our structures. That's why we have to carry out checkups about the hydrothermal behavior of our envelopes, whether it is for facades or whether it is for roofs. And these are the elements that I have prepared, and you can see them. And we're going to talk about something that you already know, which is condensation, which is the physical phenomenon by which there is a change of state of the water vapor in the air into liquid state. And it happens when the vapor pressure is higher than the vapor pressure saturation, and you can see it in the psychometric chart where you see for relative humidity and comfort temperature, we have a certain amount of water. And as the temperature goes down, that saturation vapor pressure goes up, and when it reaches 100%, we have condensation that could correspond to a temperature of around 12-13 degrees Celsius. And this is what we have to avoid inside our frameworks. With this example of a light framework that could be used at a passive house building in a climate like the one that we have in the peninsula, and where we have layers with vapor stop panels that have been certified as airtight by the Passive House Institute. When we analyze the hydrothermal study and compare it with a code of 20 degrees inside, 5 outside, and 55 as an average inside and 80 outside, then we see that the framework is going to operate really well in this situation. We see that we need 70-80% for the wood so that the wood is in a good condition. But these standard conditions of the code are not always going to be in our buildings, sometimes due to user comfort, sometimes due to the fact that we're in colder, warmer areas. There will be periods where there are even cold waves and where the temperature is going to be lower than 5 degrees, and as soon as the comfort temperature is higher or the outside temperature is lower, we can see that condensation is going to happen inside the framework, and the wood will be above 60% value, which is what is marked for the type of serve it has been created for. How do we solve this? Very easily, replacing the airtight panel for a vapor stop one, a vapor stop panel which has an SD of 13.8 meters, and we see that the thermal behavior is exactly the same. But when it comes to hydrothermal values, we see that the vapor pressure inside goes down, and we see how the vapor stop in that first layer is going to concentrate more in humidity because it's going to play its role to the highest it has, but we're going to make sure that the framework will have a relative humidity under 80%. With temperature values that are even worse than the ones we were talking about before. We're talking inside 20 degrees and outside 10 degrees, thinking of a much more extreme climate where we can add more tension to the framework. And to conclude, and in order to keep within the time we have been given, I would like to reach a couple of conclusions. To guarantee the long-term durability of wooden or enclosure structures, in our opinion, it's not enough to check up the weather conditions included in the technical code, because there are standard comfort conditions and standard conditions and averages for humidity and weather. And we know that there can be changes that may have an impact on the quality of the enclosure. How can we do something about it? Well, to use vapor stop materials to reduce the permeability of the water vapor in the structure. And if it is going to lower the structure, it will lead to better conditions of our enclosure and ensure that we can guarantee a longer life cycle of the materials used in our buildings. I would like to conclude my presentation with this. I would like to thank PEPS and the organizers of the 12th Passive House meeting, and thank you, ladies and gentlemen, for your attention.